Hi, so today I'm going to talk about the project that we are doing right now, which is blood type classification model. So the main classifier that I used was XGBoost and RandomForest. So this is actually a report on comparison. I have uploaded the XGBoost and it's how I tuned it, hyperparameter tuning the files in the Excel file. But in the report, I have done more than just one classifier, so I'm gonna demonstrate that. I'm just gonna show the result for XGBoost and just the confusion metrics for Forest 1 and 2, which I named the files which I tuned and improved on. The original one being Forest 1 and the improved one Forest 2. So I'll show just the confusion metrics because I was not able to run the whole of the thing again because I didn't I just downloaded the code. So sorry, I apologize for that. So without further ado, I'll go and explain about the XGBoost. So let us go through the code. So actually this is my code. Okay. First we started off with the import from the data source, which it's located in the Google Drive. And this is basically the whole cell is basically the stuff from lab 3.1. So I downloaded the data source, how I print it, import it, and stuff like that. And I go over to this is the what I took from lab 3.2. So it goes over and this just gives us the information and just simple classification like of the data. And then we'll move over to this one, the third section, which I believe I have adjusted this one. Oh no, I have taken them from 3.3, the same thing for downloading because one thing I noticed about the data is that the data will spiked, like the number of data spiked from March 27 to 28. So it could be said that the data has a lot of anomalies. So it doesn't matter how I clean it, the data is, I would say it doesn't make too much difference how much significance I put on those data. So I just decided to go on and use the same data sets. And to proceed, I have also uh, this section over here, which downloads all the refined ID from simple cleaning and preprocessing. And then we'll move over to the main section where actually went over and downloaded all these libraries. And the main thing is that the IBlearn over here wasn't installed in the Jupyter lab, Jupyter notebook, so I had to download it by myself. So we can see it's downloaded here. And then what I did first was import the libraries, right? So sklearn for training, and pandas for data, numpy for arrays data, and SageMaker for the overall notebook and the training that we can do, including the tuner, which states that I have utilized the hyperparameter tuner function. So I'll go over to the next section where I actually launched up this session over here, where the client is in S3, and all the bucket that all the things that we do here right now, training to pre-processing, everything will be saved in the S3 client. So we have launched this, and then we have went over to the basic data clean and pre-processing before we proceed, moving on, dropping out the columns, and so on, just to make sure that we don't have anything left over from the data previously. and we can move over to, and we can see all the data is printed like normally. And then we go over to training the data. So for this, I've used the ML4 X large specifications, say to estimate, to say actually tune the data actually to train how the machine learning model goes about doing this. Here's an instant count of 1, and next we will go over to hyperparameters, and I have specified how I'm gonna tune this because you cannot tune it to uh, too much, how to say, deviate from the original. So we cannot make it too big or too out of the scope because uh, the machine will take a long time. So I've also done the configuration here. Passing over, I'll have the result over here. I'll host, after the training, I'll host it again and then do the prediction, how the hosting will go, terminate, and lastly I'll do, after it's all trained, do the best transform for test set. So take a larger batch of the data for sampling and then train it in huge amounts so that we can get better accuracy and better F1 score, and all of the evaluation of the model performance will be printed below here. So the most significant thing was that accuracy, which is equivalent to 37 over here, it has jumped from 28, which actually I have run the original XGBoost model without just simple tuning, without hyperparameter tuning, just simple tuning, to get an original of 28.74. So the improvement of 8% is actually not bad considering the data and everything was not really making a good uh, correlation. I would say it's not too significant for the correlation between the blood type and the questions that we collected and the survey that we did. So this is the confusion matrix for the hyperparameter tuning. I'll go over to the original confusion matrix that we got. So this was the original one. We can see that the accuracy was 0.28, which is equivalent to 20%. So we can see actually that from the original from itself, we can see that the blood type A was predicted really well, and also slightly on O, but as we done the hyperparameter tuning, it increased significantly for not only A, B, C, A, B, and B and O. So the most significant changes that we can see is for the AB blood type. So it was predicted really well for A and AB. And then because I was also doing another classifier for RandomForest, which is this one, I've run it, but as I said earlier, I apologize, but the results were not shown because I have to run it all over again. So I'll not show in this video, but I'll upload the codes. So going back to the report, you can see that if we go down over here, yes, I have explicitly like just stated that we have implemented this hyperparameter tuning with the SMOT for the sampling, oversampling on the minority classes. So from here it improved, and then we can see that for the random forest we also have 30%, which was good considering that it wasn't tuned, because we know that random forest is actually good for predicting, going over the data which has a lot of noise, so it gives a decent prediction and decent accuracy. But as we went over and tuned like how we improved it, like expanded grid using grid search CV and also implementing hybrid SMOT, but the improvement wasn't huge as compared to XGBoost, which says a lot about the hyperparameter tuner, which goes and creates a decision tree and goes deeper into the data to collect the significance and see the correlation. So we can see that XGBoost, using the data that I had, was better compared to the random forest in this case. So we can see the results over here, 37 improvement of compared to the forest, it's significantly higher, 6%, 5%. And also, one thing that I noted was that for forest 1, like the random forest classifier that I use, it favors the blood type O, and it's much better for predicting as compared to XGBoost in certain blood types. If we look at the confusion metrics over here, I'll show you the confusion metrics. So this is actually, hold on a second. Okay, so you can see that the values on this B column, 19, 21, it's actually pretty good for forest, but it was significantly better for, say, A, B, and B. But for classifier XGBoost, it was A and AB, right? But for this one, it was B, and O was pretty good as well if you look at CM Forest 2. So it has significant improvement on O. So we can see that actually it was pretty good at this thing. And now we'll go back to the report again. Now we can see the confusion metrics for forest 2. And then okay. So going back to our report, you can see the strengths and the weaknesses which I highlighted in comparison. So the conclusion is actually that it's very simple, that as I said before, XGBoost has this accuracy, and it is much better in this case, in which the data which I'm using, not for other classmates. But in conclusion, all models remain below 50% accuracy, indicates dataset challenges like weak features, and I'll suggest that future enhancement could include like GBM and XGBoost, and collect more predictive examples to improve the accuracy and the performance.